So Jan just highlighted some of the new AnyScale features, and I'm going to give a quick demo of how you can use AnyScale and the Ray AI runtime to build an end-to-end machine learning application. And before I dive into the actual coding, I want to mention there are a few different ways to use Ray Air. The first and the simplest is to use Ray Air as part of an existing machine learning pipeline to scale just one component. So imagine this is your machine learning pipeline. You're doing everything, you've already gotten it working. You're doing everything from loading your data, processing your data, training your models, deploying your models. But as you scale, one of these components turns out to be a bottleneck. The bottleneck could be anywhere, but imagine it's hyperparameter tuning. Hyperparameter tuning refers to training many models so you can find the best one. And what you can do in this case is you can introduce Ray, you can use Ray, change a few lines of code, and scale just that one component, leaving everything else in place. And this is important because you may already be using a number of different tools. You may have ML platforms like SageMaker or Vertex. You may have data platforms. You may be using a variety of MLOps frameworks. Ray integrates with everything. And so you can leave everything in place and scale just that one component with Ray. The second way to use Ray is to not just scale a single part of your application, but actually scale the end-to-end thing with Ray Air. And so here's the same ML application we were showing before, everything from data ingest to model deployment. What you can do is you can actually build and scale this entire application and pipeline using Ray Air. And that's actually what I'm going to demo here today. But before I dive into the code and actually implement this, I want to mention there's a third way you can use Ray, which is to build not only a single machine learning application, but an entire machine learning platform on top of Ray Air. And this is what companies like Uber and Shopify have done. And so if you're interested in learning more about these kinds of use cases, I'd encourage you to check out their talks today and tomorrow. OK, so let's actually zoom in on how to build the end-to-end machine learning application. So our running example for this presentation is going to be building a movie recommendation system. Very simple on the surface, but there's a lot of complexity to make it work well. And the structure of our demo, of our application, will follow the same pattern. We're going to be ingesting data and pre-processing that data. That data is going to be historical examples of which users liked which movies. We're going to do machine learning training. We're going to train a deep learning model, a PyTorch model, to generate recommendations and actually predict which users will like which movies. And then we're going to take that model and deploy it. And we're going to use that deployed model to power the actual website, the web app that we're going to show to generate recommendations. And what we're going to build with Ray Air is everything in blue, all of the compute pieces. And we're going to show the advantages of having common infrastructure for scaling all of these different workloads. And as a bonus, this is already a lot, but as a bonus, we're going to show how to do continual retraining. So as new data comes in, closing the loop to continuously update the model to train on the latest data. And that's actually turns out to be important for a lot of recommendation systems. The fresher the data, the more relevant the recommendations can be. OK, so let's actually dive in. I want to start by implementing everything in the red box, everything from data ingestion to training to hyperparameter tuning. And then we'll get to the next part. And so to implement this, I'm going to switch over to the AnyScale UI to show you what I'm doing. OK, so here I have an AnyScale workspace started up. You don't have to read the text. I know it's small. The details there are not super important. But the point to mention, like Jan said, this is a tool for managing the entire application lifecycle, from development to deploying it. And you can think of AnyScale, the AnyScale workspace, as a box in the cloud where I can do local development. Except it's not just a single box. In this case, I have nearly 1,000 CPU cores, 16 GPUs, and a ton of RAM as well. So I've already cloned my project. I'm going to be editing the project to actually develop this application. And I'm going to start by opening an IDE. So through AnyScale, I'm opening up a VS Code. OK, so that's the editor I'll be using. And VS Code is running on my laptop, but the code that we're editing actually lives in the cloud on AnyScale. So VS Code is connected through remote SSH to AnyScale. And I'm going to open up this file, train.py. So as we edit this code, it's changing in the cloud on AnyScale. This is the skeleton of the application that we're going to be building. So I have a few import statements. I'll explain them when I use them. And we have a few hard-coded URLs that we're going to use for fetching our data and checkpointing the model. Okay? So I'm going to scroll up a little bit just so we can focus on the actual meat of the application. So as a reminder of what we're building, there are three parts that we're building. There's the data ingest and preprocessing, then we're going to train the model, then we're going to do hyperparameter tuning. Okay, and part of what I'm trying to illustrate here is the simplicity of Ray Air, which lets us do this in relatively few lines of code. So to start off with, let's fetch the data. I'm going to create a data set using Ray data. This is one of the Ray Air libraries, and we're going to read a Parquet file from S3. Okay, so this is scaling data ingest of about 100 gigabytes across potentially up to 1,000 CPU cores. Then we're going to transform the data set. So I'm going to create a processed data set. And this is going to use a preprocessor that I'm importing. And we're going to use that to transform the data set. Okay, so I didn't define the preprocessor. That's something I imported. But it uses Ray data. And you can think of it as doing some maps and reduces and filters to compute the features that we want to use for training. And so that's everything we have to do for the data ingest and preprocessing. What we're doing in a couple lines of code here is something you would normally use an entire distributed system like Spark to accomplish. So now that we have our data, let's actually scale training on a bunch of GPUs. So here we're going to create a trainer. We're going to use Ray Train, and we're going to train a PyTorch model, and we're going to pass in train func. So train func, what this is doing, this is essentially, it's another thing I imported. It's single machine code for training PyTorch. Okay, so this is what you would do if you're just using PyTorch on your laptop. Ray Train lets you take the PyTorch code on your laptop and scale it across many GPUs or many machines. Okay, there are a few more parameters I need to fill in to make this actually work, but I'll come back to that in a little bit. And one thing I want to point out quickly is that I'm showing, in this demo, we're showing how to scale PyTorch. But if you wanted to use TensorFlow, or if you wanted to use XGBoost, these are all options, right? You could use Hugging Face to scale transformers or natural language processing. You could use scikit-learn. There are a number of different options there, and Ray Train provides, and Ray Air provides pluggable interfaces for scaling the entire machine learning ecosystem. Okay, but for the purposes of this demo, we are showing how to scale PyTorch training. And the last thing I want to show is hyperparameter tuning. So again, hyperparameter tuning refers to training many models so you can find the best one. We're going to create a tuner using Ray Tune, and we're going to pass in the trainer. Okay, so again, there are a few more arguments I need to pass in. But what I want to emphasize here is that, and this is still just the skeleton. It's not actually going to run yet. But what we've done in about 23 lines of code is something that would normally require 3 separate distributed systems. One for loading and processing your data, like Spark. One for training and scaling training across a bunch of GPUs. That could be distributed TensorFlow or Horovod or a number of different systems. And a separate system for hyperparameter tuning. Okay? And the fact that Ray provides common infrastructure for scaling all of these workloads means that I can implement this in just a simple Python application in a handful of lines of code. So let's actually finish the application and make this run. So in order to scale training, we already have our PyTorch code. I need to specify how we want to scale. So I'm going to pass in a scaling config, and we're going to tell it to use 4 GPUs. OK, so we could tell it to use 100 GPUs or whatever, but for this demo, we're using 4 GPUs. Each model is going to use 4 GPUs. We're going to train a bunch of models. We also have to tell it what data to train on. So we're going to tell it to use, for the training data, to use this processed data set that we defined above. Okay? And that's really all we have to do for training. I want to mention one more optimization that you can do, which is that here we're doing things in 2 stages. First, we're ingesting and processing our data up at the top. And then we are training the model after that. In practice, it's often valuable as a performance optimization to be able to overlap these 2 stages. So as the data is coming in and being processed, it's being fed into training, while the next data is coming in and being processed. And that's an important performance optimization. So, and it's difficult to do without having common infrastructure for both data processing and training. So the way we can achieve that is by passing a preprocessor we'll just pass the movie preprocessor into the trainer. Okay, and then we don't need to do the preprocessing up front anymore, so I can get rid of this line. Okay, so now the two stages are being overlapped. Okay, so let's fill in the details for hyperparameter tuning. The only remaining thing I need to show here is we need to tell it what hyperparameters to search over. So we're going to configure the training loop, and we're going to search over two different hyperparameters. The first is going to be the learning rate. We're going to use RayTune to do a grid search over a couple possible values. And we're also going to do a search over the batch size for training. So again, we're going to do a grid search using two possible values, 8 and 16. Okay? So that's going to try out two different values of two different hyperparameters. So we're going to do 4 experiments in total. So training 4 models, each on 4 GPUs. And the last thing I have to run is to actually just run it. So I'll say tuner.fit to get the results. And then we have to save the result, the best model, to a checkpoint. And so the details of this line are not super important, but we need to get the best results. We're getting the best result according to the training loss metric, and we are using getting the model that minimizes the training loss. So then we find the checkpoints, and we store it to S3. So we're going to pass in our checkpoint URL. The checkpoint URL we defined at the top. So the details of this line don't matter. We are just getting the best model and saving the result in S3. So that actually completes the application. Everything from data ingest to preprocessing to training to hyperparameter tuning. Okay? And so now let's actually run it. All right, so I'm going to open up a terminal. Line 15 is incorrect? Yeah. Okay, so I have a bug here. Well, let's just keep that anyway and run python train.py because then I can show you what the debugging experience looks like. So we are, thanks for pointing that out. So it's telling us the error that the audience was calling out. So this process data set is still, we deleted that variable. So we're going to remove we're going to just use the regular data set. Okay, and resave that and run it again. So actually, the interesting thing to point out there is that the flow that we're going through right now, right, editing our code, running the application, seeing the bug, rerunning, fixing the bug, and then rerunning it, it feels very much like how you would develop on your laptop. But the difference is that we are developing and debugging at scale, right, on thousands of CPU cores, tons of GPUs, but with the developer velocity or the productivity that you might expect on your laptop. Okay, so while that's running, I'm going to show the next part of the application that we're going to show. So we just built everything from data ingest to training to hyperparameter tuning. The next part, so that's producing this PyTorch model. And the next thing we want to do is to actually take that model and deploy it in production, and then show the actual web application powered by that, by that model. Okay, so for the next part, I'm just going to walk through the code. I'm not actually going to implement it this time. But looking at the code, here we have, so there's some code below for creating the UI. I just want to focus on the code at the top. So this is using RayServe, which is one of the Ray Air libraries for model deployment. We're starting RayServe. We're creating a RayServe deployment. And we are specifying a number of replicas. So here we're doing 2 replicas. But if you were serving a lot of traffic, then you would use more replicas. And then we are deploying the model. And we're telling it to load the model from the checkpoint where we just saved the trained model in the previous section. OK, so training has finished now. It was just a short run because we want to actually, because it's a short demo and we want to have it run in time. So now I'm going to run python deploy.py. And I know this is at the bottom of the screen, so it's not easy for everyone to see. But I'm running that over here. And by the way, this terminal lives, I'm running VS Code on my laptop, but the terminal is really in the cloud. It's connected via remote SSH. So everything we're doing, the code, the terminal, are on Anyscale. So this just printed out two things. It printed out a URL for us to look at metrics. So I'm going to go back to the Anyscale UI and just go to this URL and show Grafana. Okay, nothing's happening yet because we haven't started querying the model yet. But I'll tell it to update every 5 seconds. So we can, once we start querying the model, we'll see some activity here. The other URL that was printed out was the actual movie recommendation website that we're going to go to get movie recommendations, and which will talk to the to the model that we just deployed to actually get the recommendations. So I'm going to open up that URL, and this is showing, it's a simple web app we built for this demo. It's showing different movies that you might want to watch, and we can tell it a little bit about ourselves. So as we tell it more about our interests or things we like, it will query the model with those values and produce recommendations for us. So if I tell it that I'm interested in sports, for instance, I might see movies about basketball, right? Or if I tell it that I'm interested in action, then I may see, start to see some action movies, okay? Or perhaps I'm interested in animals, right? And then there might be movies about killer whales and stuff like that. So the point is, if we go back to Grafana, now you can see that the queries per second has increased, right? And it's at a relatively coarse granularity. But over time, if we wait a little while, then that will level off because we're no longer querying the model. But the point is to see that this is the model is being queried. It's running in production. We can sort of track how it's doing. OK, so what we just showed was how to take the model we trained, deploy it, and use it to actually power our application. So the last thing I want to show is closing the loop with continuous retraining. As new data comes in, how can we update and retrain our models? And the reason you would want to do this is that a lot of companies have seen for recommendation systems that as the world changes around you, your recommendation performance gets worse over time. And so being able to train and update your recommendation models on the latest data can lead to improved recommendations and more relevant recommendations. So there are two parts to this. One is we're going to need some kind of trigger for the retraining, whether it is a timer, right, retrain every 1 hour or 1 minute, or something that our model monitoring system is telling us. As model performance degrades, kick off retraining. The other thing we'll need is we don't want to, when we do retraining, we don't necessarily want to start over from scratch and train from the beginning. We often want to pick up where we left off with our previously trained model. So we're going to need to resume from a checkpoint. So let me show both of those things. So for resuming from a checkpoint, we only have to change one line of code. We have to change the trainer to tell it to resume from a checkpoint. And we're going to tell it to get the checkpoint from the URL where we stored our model. Okay, so using ray-air to read the checkpoint from S3, this is the same URL where we're storing the checkpoint, and we're going to pick up training where we left off using the current best model. Okay, that's the only line we need to change to make that happen. And the next part we've mentioned is some kind of trigger for kicking off retraining. And I'll show Anyscale scheduled jobs for how you can do that. OK, so going back to, so you can see from Grafana, nobody's querying the model anymore. And if we go to the Anyscale UI, it's just a simple feature for running this as a scheduled job. We can call it our retraining job. And we can tell it to run Python train.py. So train.py is our training application. And we can have it do that once every hour, for instance. OK, so we're going to submit that. And that's all there is to it. Now we are doing every hour, we're redoing training with the layest data, updating the model, and saving the updated model. So just to recap everything we've seen, we've demoed ray-air, how to use ray-air to scale everything from data ingest to deep learning training on GPUs to hyperparameter search to model deployments, and then continuous retraining. And hopefully you can see the advantage. We were able to do this in around 30 to 50 lines of code. Of course, it's a toy example. The real world thing would be much more complex, but this can give you a taste of what you can accomplish with Ray Air. The second thing we showed was how to use AnyScale, how to use workspaces for interactive development and debugging at scale, how to deploy production services and do monitoring, and how to use scheduled jobs for continuous retraining. So if you're interested in learning more, we'll be demoing these in much more depth at the AnyScale booth throughout the conference, and there'll be more deep dives and talks on each of these topics. So thank you so much. That concludes the demo. And next up, I'd like to welcome Greg Brockman to the stage. He'll be talking with us. Greg Brockman is the former CTO at Stripe and one of the co-founders and president of OpenAI. So OpenAI does the most cutting-edge work out there in AI, and he'll be talking to us about AI and infrastructure at OpenAI. So welcome, Greg.